Okay, so we're going to have a look at 2 exercise 2b. So this is called the discriminant. And so what I want you to remember is we've got here the quadratic formula, right? This is one of the methods that we can use to find the roots of a quadratic. All right, if you want to find what is it that makes this quadratic equal to 0, you can process this formula. Now, what I've abstracted out of the quadratic formula is this inside of the square root, right? See that there? B squared take 4ac. That's the inside part of the square root. This is what we call the discriminant. And we use the triangle to represent it. The symbol is delta, right? That's the Greek letter delta. Mrs. Pierce's class. Hang on a sec, mate. Okay. This is the discriminant, all right? B squared take 4ac. And it's going to tell us a lot about the quadratic equation. It's going to tell us a number of things. So if you have a look at your notes, I've got a number of dot points about what the discriminant tells us. Okay, those 4 dot points. We're going to refer to them in our calculation of the discriminant today. So all we're going to do is figure out what's the discriminant and what does it tell us about the graph of this quadratic. So let's start. I've got A is 1, B is 10, and C is 25. Okay, that's what's going on with this quadratic. A is 1, B is 10, C is 25. So then if I'm going to calculate the discriminant, it's going to be B squared, so 10 squared, take away 4 times 1 times 25. 10 squared is 100, and 4 times 25 is 100, so the discriminant is 0. Okay, in this circumstance, the discriminant equals 0. So let's have a look at our list of dot points there and go, where is the discriminant equals 0? It tells us that there is one root, and it's what we call a double root. Therefore, this quadratic has one double root. Alright, so that's what we'll say about this one. Because the discriminant is equal to 0, the quadratic has one double root. Okay, move on to B. We're going to have A is 1, B is minus 3, C is positive 7. So we'll have B squared, so the discriminant is going to be minus 3 in brackets squared, right? The negative belongs to the 3, right? So minus 3 squared, take away 4 times 1 times 7. So what's that going to be? Minus 19. Okay, so then we look at our list of dot points there and we go, which one of these does it satisfy? The discriminant. The first 2 are about it being greater than 0. Okay, minus 19 is not greater than 0. It's the very bottom one. Delta is less than 0. There are no real roots. Okay, we need to specify no real roots. This quadratic has no real roots. And like, what would that mean, right, in the context of quadratic formula, is if you've calculated the discriminant and it's minus 19, that means you're going to have minus 19 in this square root here, isn't it? And you can't square root a negative, which means this quadratic doesn't have any roots. All right, the visualness of it's going to come up in the next part that we do. Okay, on to this one. We've got A is 1, B is minus 5, C is positive 6. We will do B squared minus 5 squared okay, the discriminant is 1, all right? And so we've got to check the first 2 dot points because when we've got a positive number, there's 2 cases. All right, so the first one says delta is greater than 0 and it's a square number. All right, so what are the square numbers? Well, 1 times 1 is 1. Excuse me, 1. 2 times 2 is 4. 3 times 3 is 9. So these are the square numbers, right? 16, 25, 36. These are the square numbers. So if the discriminant is a square number, then it's going to satisfy the first dot point. If it is not a square number, so anything that's not one of these numbers, then it's going to be the second dot point. Okay, so the first dot point says discriminant is positive and it's a square number. There are two, this quadratic has two rational roots. Alright, the second dot point is just to say if it's not a square number, the roots are going to be irrational. Lost again? Sorry. You're up. Did you go to the computer? Yeah. Did you? This quadratic has two rational roots. Very good. Okay, so if it's a non-square number, it's going to be the second dot point. It has two irrational roots. Now there's probably one more caveat, like a technical caveat. When it's positive, we say they're real as well. Two real rational roots. So I should put that in there. All right, let's have a look at question 2. All right, so hopefully question 1, you're just crunching the formula, looking at the dot point. What is it that pops up? In question 2, we have some quadratic x squared plus 8x plus m. And we're not told the value of m, but we're going to change the value of m and determine how this affects the discriminant. So we can go ahead and calculate the discriminant of this quadratic, right? It's going to be b squared. Now I might make a list again for us. A is 1, B is 8, C is equal to m, some number, right? We don't know what it is. So we're going to have here 8 squared, take away 4 times 1 times m. We've got 64, take 4m. Now we can't simplify that any more than it is done there already. Now the question says, identify the values of m for which the discriminant has two real roots. Alright, so the discriminant is going to have two roots when, maybe I'll write it down, two roots when delta is positive. Okay, two roots when the discriminant is positive. So therefore, 64 take 4m has to be positive. Alright, so this is probably our first sort of exposure to inequalities. Maybe we've seen some of them in pathways. 64 take 4m greater than 0. I'm going to solve this inequality for m. I'm trying to get m by itself, right? There's two real roots when the discriminant is greater than 0. We calculated the discriminant here, and we know there's two roots when it's positive, so that's the expression we've got. So then we're saying, what values of m make this true? Now, when you're solving an inequality, it's the same as an equal sign, with one exception. If you multiply or divide by a negative, it flips the arrow. The arrow just points the other way. Okay? If you multiply or divide by a negative, the arrow flips the other way. So if I'm going to solve this, like just treat it as an equal sign, right? First I'm going to subtract 64 from both sides. Okay, that's going to be my first thing. Like just treat it like we would an equation, like an equal sign. And then I'm going to divide both sides by -4. Alright? So I'm going to write this one up, what I'm doing. I'm going to illustrate it. Like we did when we first started the equations. Divide by -4, divide by -4. Now I said, if you multiply or divide by a negative, it's going to flip the inequality. So that means that's going to face the other way. Alright, that's the first thing that happens. Here we've got -4 at the top, -4 at the bottom, so they're cancelling. I'm left with m. Alright, I'm left with m on the left-hand side. And we have over here -64 divided by -4. So negative at the top, negative at the bottom, that will cancel. 64 divided by 4 is 16. Alright, it's saying m has to be less than 16 for the discriminant to be positive. That's what this statement means. Alright, if you were to illustrate that, like consider this number line here, 16, 15, 14, All right, it's saying any value less than 16 will satisfy this statement. Will make the discriminant less than 0. Let me show you. Let's suppose, so could m be 17, given this statement? No, 17 is not in the possible range of values. Could m be 19? No, it's not in the possible. Could m be 10? Yes. Okay, m could be 10, very good. So let's check, if we use m is 10, does it work? All right, we're going to have let's suppose m is 10. Now you don't have to write this down, I'm just demonstrating, I'm just making the argument, right? Suppose m is 10, all right? If m is 10, what's the discriminant going to be? It's going to be 8 squared, take 4 times a times c. All right, here we've got 64, take 40, we've got 24, which is a positive number. The discriminant is positive. Okay, so we've shown you for values less than 16, could be any of them, any number less than 16, we're going to have a positive discriminant. All right, so that's enough there. Let's move on to B. B says 1 root. Okay, so let's look up at our notes. 1 root occurs, 1 double root occurs when the discriminant equals 0. So let's write that. 1 root when delta equals 0. So that means, what's the discriminant? 64 take 4m equals 0, and we can go through and solve this, right? Okay, there is 1 root when m is 16. And then part C. How about, what's the value of m for which there are no roots? Well, no roots occur when the discriminant is less than 0, when this part is negative, right? So no roots when the discriminant is less than 0. So in our context, it's when 64 take 4m is less than 0. All right, take 64 from both sides. All right, it's an inequality, so when we divide by -4, it's going to flip it, right? Now, hopefully you can see the sort of relationship between all of our answers here. So the first one, just using basic numbers, making some comments about the roots, real and rational, real and irrational, 0 or less than 1 double root or no roots. And then in the second part, we're looking at a quadratic that has some varying value. So let's have a go at exercise 2b. If you look on the checklist, I've got written down question 4 and 6. That's what I'd like us to start with. And then 1, 2, 3, they're sort of optional extension. Recommend having a go. So we won't spend too long on 2b, and then we can move on to 2d and see some relationships with the graph.